So in a previous video, I introduced the topic of inference about two means when we have independent samples, and specifically I talked about hypothesis test for the difference in means. And so now I want to show you an example with some context. And again, this is when we have independent samples. So a study was conducted to see whether people walk faster when they are departing, so when they're getting on a plane, or when they are upon arrival, when they're getting off a plane. So a researcher went to a couple different airports and measured the walking speed for various people. In each case, there were 35 people people were observed, and for people who were departing, their mean speed, and this is in feet per minute, was 260. For people arriving, it was 269 feet per minute. Here are the standard deviations and the sample sizes. So we want to just test whether there's a difference. And so our null hypothesis, it would be that these have the same mean. And for our alternative, we're going to test to see if there's a difference. So, all right. Let's make sure, we have relatively large samples here. We meet that threshold of more than 30. So I don't need to worry about whether these means would be normally distributed. This sample size, even though it's large enough to say something about the sample distribution, it's not, when you look at it relative to all travelers, it's small in that sense. So this is not going to be more than 5% of the population of travelers. So I think we're good to use a t-test for this. So I'm thinking to myself how that's just going to work. I have this bell-shaped distribution. It's a two-tailed test. So I'll have critical values on both sides. Let's say we're going to use a 5% level of significance. Then I can find my critical values in the t-distribution by using my inverse t function found in the distribution menu, option number 4. And because I'm splitting alpha between the two tails, I need to use alpha over 2, so 0.025. And for degrees of freedom, the sample sizes are equal. Normally I would take one less than the smaller. Since they're the same, I can just take one less than either one, so 34. And my t-critical would be plus or minus 2.03. I say plus or minus, of course this would be the negative, and this would be the positive, and here's my rejection region on either side. So now I want to get my test statistic and p-value. So let's go to the stat menu under test, and this is a two-sample t-test, and I have the summary statistics. So for the first sample mean, I have 260 with a standard deviation of 53 and a sample size of 35. And for the second sample, I have a mean of 269. Oops, wait, 35, 269, 34, and 35. And I'm testing whether these differ. So I can calculate, and I get a t-value, t-test value of negative 0.85 and a p-value of 0.401. So once again, I need to fail to reject. So this t-test value is somewhere over here, but it's in this region in between the two critical values where I would fail to reject the null hypothesis. And also, this p-value is much bigger than my level of significance. So also using that method, I would fail to reject the null hypothesis. So if I'm not rejecting that, that means that there is insufficient evidence that these walking speeds differ. All right, so there's an example of a hypothesis test for the difference of means when we have independent samples. Hope that helps.